So this is a 3-meter long pump at one of the pumping stations here in Sydney. We imaged this underwater without having to take it offline, which is the normal inspection method. You would lift it out of the water using a crane and then look at it.
Panton McLeod are thrilled to announce a new partnership with Sydney-based Abyss Solutions, providers of state-of-the-art digital data analytics for underwater ROV inspections.
And also have annotations where engineers have made their notes on what are the different defects that have been found. And not only that, now you can go in, because it's such high resolution, you can take measurements as well. So you can go measure the nuts and bolts, the misalignments, anything like that. This is now a true digital twin.
We've seen a number of developments in our ROV inspection capabilities over the last few years, and now we can add digital 3D modeling of assets, the creation of digital twins for those assets, and software learning for common fault finding.
Very excited to form this partnership with Panton. I know you guys do a lot of good work in the UK in reservoir inspections and ROV operations. On the right-hand side, you see the CAD drawing of the asset, and the orange dot represents where the ROV is, so where the data is being collected. And at the bottom, we have the observations from the engineer. So it's a fully interactive video. You can scroll up and down, and you know exactly where the ROV was that you're looking at, or which section of the asset you are visualizing. We also have the capability to now take your asset and create a 3D model from it. So that means a CAD style model where we take the video from the inspection and convert it into a 3D model as such. But also we can use the video to create photorealistic 3D models of specific parts of the asset, like columns, ladders, inlet structures, so on and so forth. So this is not false color or just point cloud data. This is actually the true color, and it's true texture, and it's also gives you a representation of the entire asset from almost 360 degrees. For each one of these, you know exactly where the location of those particular assets were. But more importantly, what I want to show you here is the 3D model or 3D reconstruction of the entire asset, which looks like this. Because we went in there and imaged the entire reservoir and reconstructed the 3D models, we were able to give them the digital twin of their asset. So you can go to also different annotations and see what they are. So you have the northern wall, you have the northern inlet weir, and so on and so forth. And the good thing here is these annotations can be modified and adjusted, and you can add pictures to it, so you have a full record of this asset over time. And now we're also developing machine learning algorithms which will enable you to pick and select which kind of faults you want to look at or which kind of assets you want to look at, and it will just pull out only those ones. So once you train the algorithm on how to identify these particular defects, it will be consistent all the time, no matter how many times you run it, no matter when you run it. So you can imagine that if you have 50 or 100 of these reservoirs, you can have 50 or 100 of these kind of digital twins, so to speak, and you can have multiple inspection records as well. Now, that also allows us to the ability for us to incorporate our machine learning and our big data analytics. So we can go and mine these inspections, and we can mine these data and give you a recommendation based on similarities in faults. We have a saying at Abyss Solutions: you give us the data and we'll do the magic.